Welcome everyone, students, parents, anyone else who's watching, interested in learning a little bit about inequalities. Students, we're now moving into inequalities. We'll spend a little bit of time on these inequality signs, these less than, more than signs, and doing some work with them. So here we go. Notes might be helpful at this time, so you might want to get something out so you can have something to refer back to while you're working on the assignment. Unless you want to keep coming back to me and watching this, which if you do, that's fine. An inequality is something that's not equal. It is not equal. So up until now, we've been doing things like, x equals 3, or solving things with an equal sign. Now we're going to do not equal signs. For example, this symbol right here, or this symbol, and it will have, well, sometimes there's an equal with it, or it'll be this sign right here, or this sign with, sometimes it might be equal with it there. This sign means less than, this one means less than or equal to, and this one right here means greater than. And this means greater than or equal to. And how do you remember those signs? Well, I come up with the way that works for you. If you read it left to right, like we read words, on this one you come to the smaller part first, so it means less than. On this one, when we read it like words, we come to the bigger part first, so it's a greater than sign. Another way to think of it is this big part of the symbol goes towards the bigger entity, the bigger number, the bigger comparison we're talking about, and the smaller part of the symbol goes towards the smaller part of the comparison. For example, 8 is less than 10. We know that that's true, and it means 8 is less than 10. The smaller part is towards the smaller number, the bigger part is towards the bigger number. And if this isn't too confusing, 10 is less than or equal to 10. Is that correct? Yes, because it's less than or equal to. It can be the same item. And then right here as well, if we have 23 is greater than 0, or is 23 greater than or equal to 0? Yes, it is. Is it one of these? Is it greater than or equal to? Yes. Yes, it is. It takes memorization. In time and spend time memorizing what these signs mean. This sign means less than or equal to. And this one is greater than or greater than equal to. I like having students memorize that the biggest part goes towards the biggest entity. Okay, with that information, let's discuss this. X greater than -3. And I can put any variable here, I'll just choose the X. So X greater than -3. What is X? Well, now it's not an equal sign, it's an inequality sign. This number can actually be a ton of different numbers. It could be anything that's greater than -3. The smaller part's towards -3, so this could be anything bigger than that. So what are some numbers that X could be? It could be 0, it could be 5, it could be 8, it could be 16, it could be -2, it could be -1.4, it could be 1,382.5, it could be 2.5, it could be 67, it could be all of these items and more. It means all the numbers that are greater than -3. Well, how would we show that? Oh yeah, this is how we show it right there, just by writing it out. It's everything greater than -3. There's another way we can show it though, and it's by graphing. We're gonna talk about, well, let me just go ahead and show you now, and then we can do some more graphs. If you have a number line, and you want to talk about all the numbers that are bigger than -3. 0 there. 1, 2, 3. 1, 2, 3, 4, 5. Well, you find -3 on the number line, and it can't be -3. It's got to be greater than -3, so we're not going to include -3. So we do this open circle to say I'm not including 3. Don't include 3 on this. but I want all the numbers that are bigger than negative. And so we just color in all the numbers that are bigger than -3. We're coloring this number and 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 this number. We're coloring in all these numbers. And the way we color them all in is by just drawing a line with an arrow saying it's going on forever. There we go. That is now the graph of all the numbers bigger than -3. There's many answers it could be. Well, what if I've got, what if I say that we're looking at all the numbers that are less than or equal to 12? So think in your mind of all the numbers that are less than or equal to 12. Yeah, I could write them all out here. There's an infinite number. -3, -8, 0, 5, 2.67931. There's an infinite number of numbers that are less than or equal to 12. And how do we graph all the numbers that are less than or equal to 12? Like this. If there's a number line, and I'm just now moving over the number line so I can have 12 somewhere. We'll put, 12 right there. 13, 14, 11, 10, 9. And the number line just goes on forever in both directions. So I'm at 12, so I'm talking about 12. I want everything less than 12. So less than 12. There it is, everything less than 12. But it could also include 12. It could also equal 12. So equal 12 looks like that right there where we fill in the circle to include it. Whereas here we did not fill in the circle because it does not equal -3. It can't be -3. It's only got to be bigger than it. This one, it does include 12. So that's the main understanding of this concept today. You'll see something that looks like this sometimes. -4 is greater than or equal to n. Then you might think, well, wait a second. So what? -4 is greater than or equal to all the numbers. And this is where it's a little tough. It's a little hard to try to wrap your mind around, but just think of this. -4 is bigger than or equal to all the numbers. So if that's greater than or equal to all the numbers, then what are all these numbers? And if you think you have some ideas on it, let me make it a little more understanding. This little part right here is towards the end. You can turn around the inequality. You can put this part on this side. Just keep the small part with the m. The small part has to stay with the m. So you can turn around this inequality, keep it with the m, keep it with the smaller part, and then this side of the inequality altogether. But you've got to be careful in doing that when you switch it around, you just take the whole item and put it over here. Move this so that the smaller part, the same part of the inequality is with it. And then whatever's there, just move it. We're not flipping it around. If I had 3 minus 4 minus 8, I wouldn't flip those around. I would just take that item and I would put it on this side. So I want all the numbers less than or equal to -4. Now, if you're thinking of this, -4 is bigger than all these numbers. So all these numbers are all these negative items. -12, -20. It's all these numbers here. Now I want all the numbers that are less than or equal to -4. It's the exact same thing. All of these numbers are still accurate over here. -8, -12, -10, -20. It's still the same. It's just written in a way where it's easier for our minds to wrap around what is. All the numbers less than or equal to 4. But looking at it this way is a little abstract for us and hard to understand that -4 is bigger than or equal to all the numbers. But if you write it with a variable first, and I'll say that from now on, 7th, 8th, 9th grade, as a senior, when you're doing math with these inequalities, write it so the variable is first. Because now we can graph 0, 1, 4, 5, 6, and 5, 6. 6, 2, 4, 6. All the numbers that are less than or equal to -4. So here's -4. Less than is this way. So less than, I draw the arrow. Less than or equal to -4. And there's the graph of that inequality. Turning these around, don't be afraid of it. Just put the variable on the other side and keep this with it. You're not changing anything. The facts are still the same. All right, there's the instruction for today. Hopefully it's a little helpful. You can go back, watch it again. You can look for other resources. We are graphing inequalities. Thank you.